Okay, chapter 10, section 3, we're solving quadratic equations by graphing. Give me the standard form quadratic equation.
Ax squared plus bx plus c equals 0.
Very good. And so, when we solve these, we have 4 possible names of what we find. And we find the solutions, the x-intercepts, the roots, or the zeros. These are all synonyms for the same thing. Okay? Today we're going to factor equations to find these x-intercepts. In chapter 9 you factored not making the connection between graphs. I told you that those points are graphs. Those solutions are graphs. They're points. But anyway, now we're proving it by graphing. And we will graph them. Okay? So the 3 steps to using particular points today, again, are find your x-intercepts by factoring. Okay? And then find your vertex. Give me that formula for the x value of the vertex. X equals
negative b.
Good, which is the axis of
Symmetry.
Symmetry, good. And then we're also going to use the y-intercept that we can visibly see in these equations. And sometimes they are not on the vertex, so they will have an opposite, which is really a useful point to graph. Okay? So let's start by graphing this, and we'll fill in what's behind the secret box after we graph this. Okay? And we're going to start part A. Let's find the solutions, the x-intercepts. I'm going to call them x-intercepts because they are points on the x-axis. So we just said we're going to use factoring to do that. So can somebody rearrange that equation so it's ready for factoring? Lauren.
X squared plus 4x minus 1.
Minus 5 equals 0. Good. So she's setting the equation equal to 0, which is what one needs to do to factor it, right? And this is not a perfect square trinomial. So we're just going to find binomial factors if we can. Who has the factors? Summer.
X plus 5
Times?
x minus 1.
Good job. So if we look at the outside, negative 1x, and the inside, positive 5x. So that adds up to 4x. Good job. Okay, so what would the solutions of this be? The solution of the first binomial is?
Negative 5.
And the second is?
1.
1. So these are points. These are x-intercepts. They're also called solutions, but they're points on this graph. So if I have a scale of 10, and I'm a little off calibration, so, oh well. So we're going to plot those. Those are there. So we're going to go 1, 2, 3, 4, 5 in the negative direction, and 1 in the positive direction. We have 2 points. As a matter of fact, we have enough information right now to find the axis of symmetry, don't we? Because as we showed with problem 38 last night, right, it's halfway between these points. And how far apart are these 2 points? Do you see that? 5 plus 1 is 6. So you would just start at any point and walk 3 units toward the other point. So we could, 1, 2, 3, fill in the axis of symmetry here. And that's totally awesome. If you're graphing and you can find your axis that way, then you can now use that to locate your vertex. The vertex will have an x value of negative 2, see? It's on the axis. It always is. And if you don't believe me, then use your formula. X equals negative b over 2a. We have said that the vertex will always fall on that foldable line, right? That axis of symmetry. So I'm using the graph to label it here, but you could fill in the numbers. And the numbers are negative 4 over 2 times, what is a? What is a here? It's 1. So what is negative 4 over 2? Negative 2, exactly what we found over there in our graph. Okay, Dina?
Wouldn't it be 5x and 1x because back and 4?
What is 5x?
Wouldn't it be x plus 5 and x minus 4?
are you questioning whether this factoring is okay?
No,
What are you questioning?
I don't, never mind.
5 times negative 1 is negative 5. If you FOIL these binomials, you'll get back to this trinomial. Okay? Now, how will we find the y value of this vertex? That's a parentheses.
Plug it in.
You plug it in. Plug in negative 2. So come back up here. Let's take this negative 2 and plug it in over here. Negative 2 squared here is negative 2 squared.
4 plus negative 8.
Plus negative 8 minus 5. And so what is 4 plus negative 8?
Negative 12.
Negative 4, and then negative plus negative 5 is negative 9. Okay, so our vertex is at negative 2, negative 9. This was kind of out of calibration, but it's supposed to be at negative 2, negative 9. And now where is the y-intercept, Sydney? This is the equation that's been written in standard form. You're going to have to use this equation. So what's the y-intercept? Negative 5, that's it. It's right there. So we'll put part C, your y-intercept is negative 5. So when we go plot that negative 5, what axis is it on?
The y.
Y. I feel kind of ridiculous asking, but some people still don't know where the y-intercepts are. They're always on the y-axis, right? Now look at this. How far away from the axis of symmetry is that point? 2. So 2 units on the other side is its reflected point. See that? So it's a great way to find another point to help you graph.
That's way easier than the
Yeah, nice. So now we draw the curve.
Yes.
Okay, so how many solutions does this have?
3.
What is a solution, Summer?
Oh.
What is a solution, Michael?
number that can work in the equation.
No, in quadratic equation, solution means the roots, the x-intercepts,
Oh, so negative 2?
the zeros.
So then zeros.
How many times is this touching the x-axis? Twice. So this is a 2-solution quadratic equation. The solution means it touches the x-axis. It's an x-intercept.
Anything on the right.
I know, but this word solution is now meaning something more than that. It means the x-intercepts. Okay, you got to really clarify that in your mind, that solution means the x-intercepts. Look at here. Just to let you know, this parabola has 2 solutions. Look up here. Michael, look up here. What happens if it translates up and is now right here? How many solutions does it have now? 1. It's touching the x-axis once. So is it possible you will have graphs that have 1 solution? And when we're saying solution, it doesn't mean how many points does this have, right? It means how many times does it touch the x-axis. And then what about this? What if it was translated up here?
0.
No solutions. But is it graphable? Yes. I can graph this parabola, but it doesn't ever touch the x-axis. So it's called a 0 solution. Okay? So that's what we're about to see, is these other 2 options. You have the option of 2 solutions, 1 solution, or 0 solution. Okay? Okay, so we're going to take it through the 3 steps again. Let's start with finding our x-intercepts. So, Andrew, what do we do to the equation? Okay, so you end up with x squared minus 6x plus 9. He says set this equation equal to 0. Good. And this is the equation that we need to identify things, because it's standard form, right? And so now, Andrew, tell me, what are the factors of this? Is it factorable? What are they? Squared. So that is a perfect square trinomial. And so we now see the square of a binomial, right? X minus 3 times x minus 3 gives us that trinomial. And so what's the solution, Andrew? X equals 3. There's only one solution here. Only one place this parabola will touch the y or the x-axis, at 3. Okay, one place. So, it doesn't have a reflected friend somewhere else on the x-axis. So this point must be the what?
Vertex.
It's the vertex. It has no reflected partner anywhere. So the only point on a parabola that's like that is the vertex. So, but if you didn't know that, you would still come down step B and find the vertex, right? Which, if you didn't know that, looking at your graph, you would use our little formula. X equals negative B over 2A. And tell me what numbers plug into this. Plug some numbers in. Selena. B. You're looking here at this equation, right? So, 6 over, and the A value is 1. 2 times 1. So what is 6 over 2? 3. And isn't that where we just located the x-intercept, right? So this makes logical sense, okay? And so now we're going to find the y value, and what is the y value of that point? 0. And if you plug 3 into this equation, you will find that 9 minus 18 is negative 9 plus 9 is 0. So you can do it mathematically, you can use your graph, okay? And then part C, we're finding our y-intercept. We really only have one point so far. But given our equation, again, what is the y-intercept, everybody? 9. There it is. So we come over here and we plot 9. And how far is 9 from this axis? 3. So we reflect across it, and there's a 9, 3 units across from it, right? Or 6 total units away from it. So there you go. And we do have enough information to graph the parabola. In this case, we only have 3 points, but that's enough, isn't it? Right? So how many solutions does this have? 1. So that's what this says. A 1-solution quadratic equation. Not with a quadratic. Okay, so go ahead and you're going to have to pause the video since I'm running short on time. Come back and see what we found here. Okay, so we could not factor this. So we went on to the vertex and found a vertex at negative 2, 2. And we used the y-intercept of 6 and its reflective partner across the axis to find a third point, and we graphed it. So how many solutions are there to this? 0 solutions. There are infinite points, but there are no x-intercepts. The definition of solutions is x-intercepts. We have to have that word completely memorized, because it doesn't mean just what would make this equation true. It means where does it touch the x-axis. Okay? So this is just a summary of the number of solutions a quadratic equation might have. And when it has 0 solutions, there are no x-intercepts, right? So when it has 1 solution, how many x-intercepts?
1.
That's what it means. It's the vertex in that case, okay? If it has 2 solutions, then it's got 2 x-intercepts. That's what that means. Okay, so what this means is if you look at this little section, 5 through 20, there are three sets of questions, and just do 5, 8, 11, whatever. Whoops. So you'll see that you're doing the right column, not all of them. Let me see what it says. You're doing 5, 8, 11, 14, 17. So it is like multiples of 3, but they're not multiples of 3 because they start with 5. Okay?